My name is Brian, and I'm going to do a talk on repeating. And we're going to cover things like Terraform 11, what used to be iteration, Terraform 12 and 13. So let's go ahead and step through. So my name is Brian. I work for Anaplan as a principal engineer. I have a number of my own hobbies that I like to do, including brewing, contributing to open source, and also fostering. The usual social media links is where you can find me. Almost everything that you can find me online is going to be my last name and first initial. And so most likely that'll be me. Would always like to, work with other fellow engineers and good people. So if you're looking for a career or a change in career, or you're new to the market, come check out Anaplan. We do some very interesting things across many clouds, and we have a pretty large infrastructure, so we could always use the help. So as I said, we're going to cover some older iteration in Terraform 11. We're going to go over kind of what iteration is today with Terraform 12 and 13. And we're going to describe how that works, numeric indexes versus named indexes, and kind of the strategies that we would use with for and for each, and recount what we used to do with count and numeric indexes. Some of the syntax that helps with that are things like length, flatten, and locals. Length to get you your numbers, flatten to kind of manipulate your structures, and locals to help you with generating those variables that you're going to use for manipulation. And then some of the tools and things that I use. Terraform Console for seeing what it is that I'm going to work on in terms of the functions that I use. Terraform Output to make sure that it displays correctly. Terraform State, which generates an output file. We can parse and view that, and use those in our IDEs, and then investigate what the structures are and how it's coming out. And then JQ. And JQ is very useful for parsing JSON and making sure that we're going to get the right kind of output structure. So let's step into a little bit of history with Terraform 11 and a lot of the versions before that. So you used to use an indicator count on your resource items. And what it would do is actually return a string of that number of how many of that resource you would like to do. So you would provide that length a list, and it would iterate over the number of items and then return a number. And then that resource would happen that many number of times. Also, as a result of that sort of lack of object expressivity, you would then have to create other variables like repo private as a map. And that map would use the element from your list, one of those index items from your list, and then repo private is indicates whether or not this is a private or public repo. So we would have the repos on the left side of our map and a true false on the right side of our map, determining whether or not that was a public repo or a private repo when we iterated through this. And of course, in order to represent that information, we would have to join those items in what's called Splat Notation. And so in Terraform 11 and prior, you would have to do outputs as a 3-field item unless you had numerics, which is what Splat Notation was, and it brought that 4th field in there. These fields are separated by periods. And so GitHub repository.star meant all of the counts, all of the indexes of GitHub repository, named repos, and .name. So let's not spend too much time on history and go into what's kind of current. And so with Terraform 12, we expanded a bunch. And so HCL2 was introduced, which is a complete refactor of the HCL language. And so with that, a bunch of the double quoting that you kind of saw in the last example has been reduced significantly. What we used to know as interpolation is now called function. Types are actually meaningful. So when we said things like booleans or numbers or strings, they actually return as that actual type now in Terraform 12 and beyond. As opposed to in Terraform 11, it was questionable as whether or not you got a real numeric. In fact, most times you would get a string as a return. Modules can now have very specific provider information. So when you configure your module, you can provide it a specific alias for your module that says use the credentials from this alias or use the information from the provider from this alias. which you previously couldn't do. Of course, there are a number of others. There's the Introducing Terraform 12 link down below, which is a fairly large and expansive document. Goes over a lot of the high-level changes. And then, of course, the configuration syntax is fairly current and consistent. So going into our typing specifically, now we have actual types. So we can say our variable is a number or string or Boolean. And then likewise, we can express those more richly. So we can say that we have a list of numbers or a list of strings or a list of Booleans or a set of or map of, object of, and tuple. And so those are our data structure objects, constructors. And then what they are our types, our number, string, and bool. And then we also introduced the concept of null. So in Terraform 11 and before, if you didn't want something or you wanted something kind of unset, you didn't have a way of saying that it was undefined or to not provide it. You would provide empty or a quote with nothing in between. And so now we introduce null, where null actually means null. Null is a special type, and it means undefined ultimately. So let's get a little bit into the looping. So one of our first constructs is for each, and we do these on resources. And so in a for each of the resource, we can take a structure like a map of objects or a map itself or a list of objects or list of maps or things like that. And we can iterate over those and say, great, from those, in each value that I grab, I'm going to grab each value the field name. So I'm going to look for the key name, which is a string, and I'm going to ask, hey, is this null? I'm going to use the key from my structure, or I'm going to use the actual value from my structure. And then for private, again, I'm going to look into my structure and say, hey, is private there? And is it null? Then I'm going to assume that it's not a private repository. Otherwise, I'm going to take the value that I specified from it in my structure. When we go into for is a way to iterate over our objects, but not really for the resource itself. It's for manipulating or indexing through the data structure that we're going to work with. So in this particular case, we're going to create a data structure that combines our teams and our repositories and decide what we're going to do. And so in the locals definition that you can see, I'm creating what's called the global team repository variable. It says for R in GitHub repository repos, so that's our resource and our resource name, and we're going to give it an index of R. And then for the GitHub team, we're going to give a resource of T. And we're going to go through each of those objects, and we're going to take a look at our variable teams and see if we have some permissions. We're going to go over the repository and capture that name. We're going to grab the team ID, and we're going to grab the team name. And so we're going through both of these objects, literally all the teams with every repo, and seeing if we're going to include this is our new object, because what we're going to do is we're going to assign these teams to each repo. And so that's what the GitHub team repository resource does. It says, I need a team ID, I need a repository, and I need a permission for that team that I'm going to assign. And so that's the data structure that we built. And so when we have that structure, there's no left side index when we do that. And this is where we come into for. And so for X in the local structure that we built, we're going to put something on the left, which is a combining of the team name and the repository, and then we're going to give the whole object is what it points to. And that way, our index for a global team repository is going to be that combination of that team name, a colon, and the repository, and then all of the settings for it are going to be contained within that map. In dynamic, what this does for us is allow us to configure a block of code that doesn't have to necessarily exist or may exist multiple times. So in GitHub repository repos, we might have a template repository. And so there might be a configuration there on the object that we've configured that says that this is a template. And so in this for each structure, what we're going to do is we're going to check if the value template, the key template inside of that structure, is null. And if it's null, we're going to pass it empty, which means that dynamic template as a resource block is completely excluded from this index when we for each through the var repos. If we do find it, what we want is this resource only accepts one template block. So we're going to give it a list with one index. It doesn't really matter what that index is, we're just going to give it an index. And so we put an index number 0 in there to make sure that the list is at least a length of 1. And then for the content, we go through and we're actually going to go and reference our data structure, our parent structure, not the iterator that we get from template. And so we're going to look at the key template and the value, or the key template owner, because template is a map itself. And we're going to provide those to the owner argument and the repository argument dynamically. Now you can also use dynamic to actually configure multiple instances of that block. So one popular strategy is tagging in AWS. And so when you filter for your AMI, you may want to filter on a number of items. And so we're going to filter in this particular case on 5 filters. And so that would normally mean that our resource would be configured with 5 filter blocks. You would have filter, curly brace, name equals some kind of thing, and value equals some kind of thing. And so instead of specifying that multiple times, dynamic allows us to configure that in a very malleable way so that if I modify my AMI filter structure and add more indexes or remove more indexes, so let's say that we don't filter on state anymore or virtualization type, I could specify that variable with just the name, owner, and root device type items, and then the AWS AMI data resource will have now 3 filter blocks computed on it. One for the name filter, one for the owner alias filter, and one for the root device type filter. And so it'll do that any number of times as long as the resource handles it. And so your differences are is whether or not you're doing multiple of the block or one of the block and what strategy you use. And so in this dynamic filter site, we use dynamic filter, and filter is the object index. And so we're using the keys and values from this flat map and making sure that we create these items. So let's see what we improved with Terraform 13. So now, instead of specifying modules multiple times, kind of like a stamp, and like if you wanted multiple colors, you would hit a different ink pad with different colors and then stamp it again. Now we're going to call them more like resources, and we're going to allow ourselves to iterate over them just like we would any other regular resource that you saw previously. Also, depends on can now block on your modules. So before in Terraform 12 and earlier, once your resource computed an output or computed some kind of value or variable item to output, your modules then could technically broadcast that, and your next module that depended on that would be able to fire. And so you wound up with situations where people would put in purposeful delays at the end of their modules and rely on some kind of output captured from that in order to make sure that their module fully completes before it goes on to the next module. Well, now you can put depends on modules just like you would on resources, and now that whole module has to complete all resources within it before the next thing can fire. And so if you have a dependency relationship between 2 different modules or a module and a resource, that module will fully complete now, whereas before depends on was not an allowed option. And of course that iteration, now we could for each for the module. So instead of passing a whole data structure like what we had described before into the module, and the module has to be built in order to handle that, now we can make those modules more singleton so that the module is going to do exactly what we say it is that it's going to do. And if we want to iterate that, we do that with our plan. Instead of in our plan, we create a massive data structure, pass it into the module parses and handles that data structure and produces the output. So here's an example. Just like a regular Terraform plan for a single resource, we're going to create all the variables that we'll take as inputs and generate our resource. And so in this particular case, we're going to create a GitHub repository. We're going to ignore some lifecycle items, but then provide all of our options. And this allows me as a module creator to allow or put in some restrictions like some conditional formatting or conditional objects on top of those items. And then of course we brought back the dynamic template, because if I want to create a repository that is off of a template repo, I can provide this item and actually specify that without changing the module itself. I can handle both. And so when we call this module, and we want to call it multiple times, we do our data structure in our plan, and we provide that in a for each to the module. And so now the module becomes the index iterable object. And so when we pass that in, we have to tell it, great, each value from my resource that I'm creating, I'm going to pass that allow merge commit key from that object and the allow rebase merge key object. And of course, if any one of those items are actually null, it results in nothing being input and allows my module to take a default action as opposed to me having to provide that. And of course, name key or name equals each key, I'm going to force the user to give me a name because I have to name the module something. And the resource itself requires that. So now let's compare our numeric versus named indexes. So numeric indexes, you get just simply numbers. And of course, you can do that just the same in a number of multiple times. And for each, you get actually a referenceable name. So first repository, second repository, third repository. And while structurally in the object, these don't make too terribly much difference, it does make a difference when you go and you modify these objects. So when we want to come in and, let's say, remove the second repository, which is our index number 1, we go in, we make our change, we remove our first index. But what we've really done is we've made what used to be index number 2, otherwise defined as the third repository, and now renamed that now as index number 1. And so now this is going to reshuffle our items. And so you can see really confusing like destroy create or change destroy sort of results. And of course your relationships on account sort of resource is very difficult to maintain. If you want resources built on other resources, like we have teams built off of repositories and that sort of membership relationship, you're going to have to do some complicated modulo or interleaving in between those items. And so as an example, we removed our first index. But what Terraform does in 11 and earlier, and well also in 12 because we're using a numeric index, is it's going to compare its state and then find that the diff says, great, index 1, it's not that it's removed, it's that it's changed. Because the list that you provided me is a list of 2, not a list of 3. And so it interprets the second index, index number 1, as changing to all the values now of the third repository. And so now we're going to have to change all of our settings. Now in GitHub, in terms of what's actually there, is still our second repository. We're just naming it now our third repository. And then what happens to our third repository? Well, it gets deleted because our index list is now not 3 long, it's 2 long. And so it doesn't find that second index. And so now it removes all the content. And of course, in the GitHub world, that actually means that the third repository got deleted and not the second repository. And that results in our change and destroy sort of relationship. Now, each resource is different, so you'll have to figure that out. Now, when we go to named indexes, we now actually have referenceable names. So when I say I want to delete that first index, I'm actually saying I want to delete the index called second repository. And then in this example, I have that relationship back. I have my GitHub teams related to my repositories. And so when I go through, I'm actually only going to delete my second repository because my object, I only removed that index. Doesn't matter where in the list it is because on the left-hand side, my index name is second repository. And then also because there was a relationship previously where we said that there were teams with that, we delete only the ones related to the second repository. So when we used to have 6 objects in that sort of relationship, and we want to remove one repository, well, we need to remove the teams associated with that. And so now we remove 4 things from our list. So here's kind of a code listing or setup because we can go back and see that there's a very easy and express relationship, especially from my comment. I'm going to generate an object and assign the team and permission to all repositories where that item global has my Boolean true. And so that's the test at the end of my for statement inside that inner for loop. And so I could create this object, and if I have other teams that are not global, this won't be included, but the teams that are global will be included. So let's cover some syntax specifics here. So going back to length, and this again is Terraform 11 syntax, we're going to be returning strings when we return these numbers, which is not exactly optimal, but that's the way that the language runs. And of course, we're going to run on count indexes, and we're going to have to make maps in order to kind of express our complex object listings and things like that. Whereas in 12 and 13, we're actually going to return specific types when we use these items. So, in 12 and 13, a count returns a number as opposed to a string. And then, again, resources based on length and using your count is going to have numeric iteration, and it's going to be kind of complex to express relationships. In a flattened scenario, what it does is it removes all of the empty outer constructs like empty arrays or arrays of only your object and compresses them down so you have a simplified data structure. And so when you work with complex data structures, you're definitely going to want to use a lot of the tools, Terraform Console a lot. You're going to want to look at what the state and outputs and look at the relationships between these items. And then sometimes you're going to have to work with your loops and iterators, your for calls. And you may need to give two indexes, things like for r, I in GitHub repository repos, where I becomes the left-hand side of that relationship and r becomes the left-hand side. So let's cover the tools again. So Terraform Console, again, is going to be your built-in, Terraform is your built-in binary. And so the console output and state are free commands that you have in order to look through and go through your objects. So in console, you can actually do your function math. Now, if it's local, you're going to have to make a couple of the steps. And then for things like count.index, you're going to have to provide the actual index of your resource in order to see the data object and what goes out there. In Terraform output, you have your full output and what you want to pass on. State contains a lot of the same information, but also the resource objects and fields and other things that you can probably call and go through and look at. Now, JQ is extremely useful, especially if you output or tell Terraform to output as a JSON and your state file is in JSON. So you can go through and do filters in JQ to make sure that you are getting the right content in the right places. And of course, most useful as always is running and operating tests. And so for a lot of the code that you've seen me show as an example, I will provide Terraform 13 compatible code for that. And that'll be up on my personal GitHub repository when I release. And you'll also see Terra tests in there that will show that my object is getting the right result. And of course, there's some wonderful resources. The learn.hashicorp.com site is constantly revamped. It's probably the best place to go through educational material. I highly recommend going through some of the tutorials. Specifically, there are some upgrade gotchas on Terraform 13 if you're coming from 12. If you're fresh and starting, fantastic. You still might want to take a look at them because there are some better strategies that we have learned since Terraform 12 that will be included in there. And as always, citing TerraTest, Terraform's doc, and all the syntax, and then your module registry, which is great for browsing both providers and provider documentation as well. And of course, there's my GitHub resource link. So I'd like to thank you for spending the last couple of minutes with me, and hopefully you found this informative.